A mass M is suspended by using a string which passes over two pulleys. If the two free ends of the string move downwards with a speed, what will be the speed of the mass in upward direction? That is, we have to find that is the upward velocity of the mass if the two strings are pulled downwards with a certain velocity. In the diagram, M is the mass which is suspended by using a string, and that string passes over two pulleys P1 and P2. The string is passing over two fixed pulleys P1 and P2. P and Q are the two free ends of the string which passes over two fixed pulleys P1 and P2. This is pulley P2 and P1. Other pulley is P1. The free ends P and Q are pulled downwards with a velocity U. U is the velocity of the free ends of the string in vertically downward direction. In that case, this portion of the string will be moving with the same velocity U. That is, oblique portion of the string will be moving with the same velocity U if the two free ends of the strings are pulled with that velocity U. Now we can draw a perpendicular from the point C. Cn will be the perpendicular. AB is the distance between the two fixed pulleys, and Cn is the perpendicular from the mass on the distance AB. The portion CA of the string makes an angle theta with the vertical direction. Again, this portion CB, the oblique portion CB, makes an angle theta with the vertical portion. L be the length of this portion CA and CB of the string. L is the length of the oblique portion CA of the length of the string, and 2x is the distance between the two fixed pulleys. That means AB is equal to 2x, or 2x is also the distance between the two pulleys P1 and P2. In this case, if two free ends are pulled downwards with a velocity u, the mass capital M will be moving upwards with a velocity v. V is the velocity, upward velocity of the mass M. If two free ends of the strings are pulled downwards with a velocity u, the mass M will be moving upwards with the velocity v. Let a mass capital M be suspended by using a string that which passes over two pulleys P1 and P2. A mass M be let a mass M be suspended by using a string, an inextensible string. This is the string in the diagram, using by which a mass capital M is suspended, and that string is passing over two pulleys P1, P2 as shown in the figure. Passes over a mass of M be suspended by using a string which passes over two pulleys P1 and P2 as according to the diagram. If the two free ends P and Q moves downwards with a velocity u, two free ends P and Q move downwards with a velocity u, comma, the oblique portion CA and CB of the string, the portion CA and CB of the string, that is the oblique portion of the string, the portion CA and CB of the string will be moving, will also be moving, will also be moving with the same velocity u as that of the free ends p and q of the string. If the two free ends p and q move downwards with the velocity u, portions CA and CB, which are the oblique portion of the string, will also be moving with the same velocity u obliquely at an angle theta with the vertical. The same velocity u obliquely at an angle theta with the vertical direction. The portion CA and CB subtends at an angle theta with the vertical direction. Vertical direction is what here? Cn is the vertical direction, and that means if the two free ends P and Q are pulled downwards with a velocity u, two free ends P and Q in the diagram are pulled downwards with a velocity u. They are pulled downwards with a velocity u. In that case, the oblique portion of the string, that is CA, the oblique portion CA will be moving with a velocity u, and that makes an angle theta. And similarly, CB will be moving with velocity u, and that oblique portion CB will be at an angle theta with the vertical direction CN. Now, from the triangle ANC, from the triangle ANC, from the triangle ANC, x square plus y square equal L square. Perpendicular square plus base square is equal to hypotenuse square. X square plus y square is equal to L square, where L is the length of the oblique portion of the string, length of the oblique portion CA of the string, oblique portion CA of the string, y is the vertical distance of the mass from the pulley, and 2x is the distance between the two pulleys P1 and P2. 2x is the distance between the two pulleys P1 and P2, and y will be the total displacement of the mass, total vertical displacement of the mass m from the point C to N, total vertical displacement of the mass capital M when it travels from C to N. In this case, the mass total displacement of the mass m will be y, that is from C to N. If two free ends P and Q are pulled downwards, in that case the mass m will be moving from C to N, and the vertical displacement, the mass m will be moving from the point C to N, and vertical displacement will be y, that is y equal to Cn, and we get x square. Differentiating the equation 1, differentiating the equation 1 with respect to time, we get ddt d by dt of x square plus y square equal d by dt L square, or here the equation was x square plus y square equal L square. So here ddt of x square plus y square equal ddt of L square. ddt of x square plus ddt of y square equal ddt of L square, where 2x, which is the distance between the two pulleys P1 P2, is constant, which is also the distance between the two pulleys is constant. Distance between the two pulleys is constant. As 2x is constant, that is the distance between the two pulleys is constant, we can say x square is also constant. Is also constant. Therefore, ddt of x square equals 0 because x is constant and x square is constant. That's why ddt of x square is 0. Therefore, 0 plus from the previous equation, 0 plus ddt of y square equal to ddt of L square. L square. Or comma 2y dy by dt equal to L dl by dt. Or comma now if we draw the diagram again, simplified diagram, these are the two pulleys. This is the distance 2x between the two pulleys, and from this point a mass capital M is suspended by using a string. This is a string using by which a mass capital M is suspended, and its weight mg is acting downwards. Its weight is acting mg is acting downwards, and the two free ends q and p and q are pulled downwards with the velocity u. In that case, oblique portion of the string will be moving with the same velocity u, and L is the length of the oblique portion, and this is the total. This will be the total vertical displacement of the mass m. The mass m will be moving upwards with the velocity v. Mass m will be moving upwards with the velocity v. Again, u is the velocity with which the string is pulled downwards. Therefore, u equal to dl by dt, because u is parallel to L, which is the velocity. U equal dl by dt, which is the velocity with which is the velocity of the string, is the velocity of the string, or it is the velocity of the free ends of the string. And C is the point from which the mass is suspended, and AB is the distance between the two pulleys. U equal dl by dt, which is the velocity of the string along CA and CA or CB, along the oblique portion C and CB of the string. And now V, upward velocity of the mass m. V is parallel to y. That's why V equal dy by dt, rate of change in displacement with respect to time. V equal to dy by dt, which is the upward velocity of the mass m. Which is the upward velocity of mass m. of the mass m which suspended, which is the upward velocity of the mass m suspended. You get the expression of u and v from the previous equation. That will be equation 2y dy by dt equal to L dl by dt. That is equation 2. And putting this velocities u and v, expression of u and v in equation 2, or we can write from equation 2. From equation 2 we can write what we get: 2y dy by dt equal to L dl by dt. Now putting the expression of dy by dt and dl by dt, we get what? Or y dy by dt equal L dl by dt. Or comma y. Now dy by dt is v, that is the upward velocity of the mass m. L and dl by dt is u, that is the velocity of the string. So finally we get v equal u divided by L by y by L. V equal u divided by y by L. From triangle ANC, cos theta is equal to base by hypotenuse means Cn by Ca. Base is Cn and Ca is hypotenuse. That is y by L. Cos theta is y by L. So from the triangle ANC, if we denote the angle subtended by the oblique portion Ca with the vertical, so y is the base, L is the hypotenuse, and this angle is theta, and perpendicular is x. In that case, cos theta is equal to Cn by Ca, base by hypotenuse. Cn by Ca is equal to y by L. So cos theta is equal to y by L. Therefore, V equal u divided by cos theta. V equal u divided by cos theta. V is the velocity of the mass which will be moving upwards if the two free ends of the strings are pulled with a velocity u, where theta is the angle subtended by the oblique portion of the string with the vertical. So V equal u by cos theta is the velocity with which the mass m, capital M, will be moving upwards. Will be moving upwards if the two free ends of the string, two free ends P and Q of the string, are pulled downwards with a velocity u. Are pulled downwards with a velocity u, where theta is the angle subtended by the oblique portion Ca of the string with the vertical. V equal u by cos theta, which is the velocity with which mass m will move upwards if the free ends P and Q of the string are pulled downwards with the velocity u. And theta is the angle subtended by the string with the vertical. Theta is the angle subtended by the oblique portion of the string with the vertical. By the oblique portion of the string with the vertical. Of the string with the vertical. vertical.